Hello students, welcome to Aditya Academy. I am Dr. Ragini Arora and today we are starting with the exercises of chapter 5, which is Arithmetic Progressions. The introductory video of this chapter I have already uploaded. I hope you must have watched, and that video actually tells you about all the concepts which are being used in this chapter. So in this video I am starting with the exercise 5.1 from NCERT. Right? So the first question says, in which of the following situations does the list of numbers involved making an arithmetic progression and why? So in the first question, it has different parts, and in every part we have to tell whether the sequence which is given in the question forms an AP or not. Just to give you a recap, an arithmetic progression is a sequence or list of numbers in which the difference between any two consecutive numbers is always same. Like if you add 3 to the existing, first term is not bound at all. Then if we keep on adding a fixed number to the previous number, we get a sequence. 2 is the first term. If we add a fixed constant 3 to the every existing term, we get a new term which is the next term of the sequence. Such a sequence is called an arithmetic progression. And this first term, which is not bound by any restriction, this is called A1 or represented by A. And this common difference, this 3 is common difference here. This is represented as D, which is common difference. D is common difference, the constant term which we are adding to every existing term. So here it is represented by 3 and the first term here is 2. And if we know these two quantities in an AP, we can find anything which is required in the question. Right? So this is the basic of arithmetic progression. That means if we have to check whether a sequence is an AP or not, we need to check the difference between the consecutive terms. Like we have to find A2 minus A1, A3 minus A2 and A4 minus A3. If for the 4 terms these 3 differences come out to be common or same, that means that sequence is an arithmetic progression. And if these differences are different, then it is not an arithmetic progression. Right? So this is the basis. Now we start with the question. The taxi fare after each kilometer, when the fare is rupees 15 for the first kilometer and rupees 8 for each additional kilometer. See, we had done such type of questions in linear equations. Like y gives you the total cost, in which 15 rupees 15 is the cost of 1 kilometer. So 15 multiplied by 1. For the first kilometer, the fare is fixed as rupees 15. And for the subsequent distance, it is rupees 8 per kilometer. So if we have to check whether it is an AP or not, first of all, we have to take the values of first 4 terms. Like for 1 kilometer, your cost is 15 only. And for 2 kilometers, y becomes, this is n times x. 15 rupees is for the first kilometer, and since we have traveled 2 kilometers, 1 is already done here. For the next kilometer, we have to multiply 1 by 8. That is, for 2 kilometers, the distance of first kilometer is 15 and for the next kilometer is 8. So it gives us 23. For 3 kilometers, cost becomes 15 for the first kilometer, and for 2 kilometers, it is 2 times 8. So 15 plus 16 is 31. One more, 4 kilometer is 15. 1 kilometer is covered here. So we have to multiply 8 by 3. That is 15 plus 24. This is 39. So the sequence here, what we have got is 15, 23, 31 and then 39. So check the difference here, right? 23 minus 15. 23 minus 15 is 8. Then 31 minus 23. This is also 8. Then we have 39 minus 31, which is also 8. So you can see that according to the conditions, first of all, we formed the sequence. Then we took the difference between all the three consecutive terms like A2 minus A1, A3 minus A2 and A4 minus A3. And since that difference is same, that means this is an AP. This satisfies the criteria for being an AP. This is arithmetic progression, right? Now the next question is, the amount of air present in a cylinder when a vacuum pump removes 1/4 of the air remaining in the cylinder at a time. So even before trying to make an AP of this question, you can very well say that 1/4 of the air remaining in the cylinder. That means if we, let's say we start with, let us assume that we have volume V meter cube in the beginning. Now, in the first attempt, the vacuum pump removes 1/4 of the air remaining in the cylinder. So when 1/4 is removed, then what is left? This means 3/4 of volume is left, right? We have taken out 1/4 of V. Now, when we have to extract the air, we have to take 1/4 of the existing volume. Now the existing volume is 3/4. So 1/4 of 3/4 of volume becomes 3/16, right? So that means 3/4 minus 3/16. So we have 4 4s are 4 3s are 12. This is 9/16. This is 9/16 V. See, initially we had volume V. Then we took out 1/4 of the given volume. The volume was V and we have taken out 1/4 of volume V. So 1 minus 1/4 is 3/4 V. Now this is left in the cylinder. In the second attempt, you have to take out 1/4 of this existing volume. That means 1/4 of 3/4. That is 3/16. So this is the amount that we have taken out, 3/16 of V. This is the second amount, 3/16 of V. So basically these are the differences. These are the differences. After taking out 1/4 V, we are left with this. So the difference here is 1/4 V. 3/4 minus V is minus 1/4 V. And difference here, after taking out 1/4 of existing volume from the second case, 3/4 V. So 1/4 of 3/4 V is 3/16 V. So this much volume we have taken out. So we are left with 3/4 V minus 3/16 V. That makes, this is 16, 4 4s are 4 3s are 12 and 16 1s are, this is 3. So this is 9/16 V. That means the difference between the quantities here, it is 1/4 of V and here it is 9/16 of V. Sorry, and this is 3/16 of V, 3/16. So you can see that the differences here are not same, because whatever we are taking out from the cylinder, it is not a fixed quantity. It is dependent on the existing volume of the air inside the cylinder, which can never be fixed. Since the common difference is not same. So this is not an AP. Right. Next is the cost of digging a well. After every meter of digging, when it costs rupees 150 for the first meter and rises by rupees 50 for each subsequent meter. See, you have to analyze by the language. First thing is fixed. For the first meter it is 150, and for the rest of the meters it is moving with a fixed constant multiple. So it will form an AB. So we can work it out. I want to say that, like in previous question, the next existing term was dependent on the volume of the quantity of the previous term, and it is changing according to the existing quantity. It is not fixed, so that doesn't form an AB. But in this case, the cost of digging a well after every meter of digging, when it costs rupees for the first meter. So for the first meter, the cost of digging is rupees 150. Then for the second meter, like in the case of a fair, we had first meter fixed. For the first meter it is 150, and for the second meter it is 50. 50 multiplied by 1. So it becomes 150 plus 50, that is rupees 200. For the third meter, 3 meters, 150 for the first one and 50 for every subsequent meter. So that means we have 2 meters. So 2 multiplied by 50. So 150 plus 100, that is 250. And for the fourth meter, 4 meter digging, cost of first meter is 150 and cost of rest of the 3 meters is 3 multiplied by 50. So this becomes 150 plus 150, that is 300 rupees. So you can see that the first one is 150. So A2 minus A1 is 200 minus 150, that is rupees 50. A3 minus A2 is, A3 is 250. 250 minus 200, that is rupees 50. And then A4 minus A3 is 300 minus 250. So you can see that the differences between every two consecutive terms is same. So this is an arithmetic progression, right? Next is the amount of money in the account every year when rupees 10,000 is deposited at compound interest at 8% per annum. So when we had learned compound interest in class 8, we had learned that if we are depositing rupees 10,000 in the beginning, after 1 year, rate of interest here is 8% per annum. So if we take time as 1 year, the interest is calculated as simple interest, which is PRT upon 100. That means 10,000, rate is 8 and 1 upon 100. So interest in this case is 800 rupees. But if it is a case of simple interest, it is the multiple of the number of years as the interest of 1 year. So interest for 2 years will be 1600, interest for the 3 years will be 2400, and so on. Simple interest is simply a multiple of interest of 1 year in number of years. But if it is compound interest, it is calculated as, since you deposited 10,000 with the bank, if it stays for 1 year, then after the end of 1 year, this 800 rupees will be added to your existing account. So the principal for the second year, becomes amount of the first year. That means 10,000 plus 800. So it is 10,800. So now you can see that if the principal is changing, the basic quantity is changing for every existing term, that means the common difference will not be same. Right? Now if we are using this as principal, putting this rate for another 1 year, interest will not come out to be 800. Interest is, now the principal has become The bank will now provide us interest on this existing amount in our bank account. It will not be the same as 10,000. So 10,800, rate is 8, again 1. So this becomes 8 8 are 64. The interest for the second year becomes 864. In the first year it was 800, second year it is 864. So the amount of money in the account every year when, see, after first year it will be 10,800. Right? It was 10,000 in the first year beginning, then 10,800, and then if we add 10,800 and 864 interest, 11,664. 11,664. You can see that the difference between these two terms is 800 and this is 864. So this is not an AP. So the thing is, wherever by the language, if you don't want to spend, because these questions will come in one marker only, if you can just analyze it mentally without getting into calculation, you can take the right answer. That means if the basic thing upon which we are forming that an AP, it is not constant for every term. Like in this case, the principal is not same for every term. So interest cannot be same. So we cannot have an AP, right? Next question says, find first four terms of the AP when the first term A and the common difference D are given. So finding an AP means you have to find it minimum 4 to 5 terms. Let's say 4 terms, then that AP is known to us. So A is 10, and we have learned that a sequence is formed. An AP is formed whenever we keep on adding a constant number to the existing number. So the sequence, the first term A is never bound, and if we have A1, A2 is obtained by adding the common difference to it. A3 is obtained by adding common difference to A2. A4 is obtained by adding common difference to A3, right? So we have to keep on moving by adding D to the existing term. So A2 becomes A plus D. A is 10, D is also 10, right? So it means A2 is 20. Now A3 is A2 plus D. A2 is what? 20. D is 10. So A3 is 30. A4 is add D to A3. That means A3 plus D. This is 30 plus 10, 40. Right? So the sequence is given as A1 is 10, A2 is 20, A3 is 30, and A4 is 40. Right? This is a sequence. We can put comma and then the sequence goes on like this. Second is A is -2 and D is 0. In the introductory video, we have learned that an AP can be formed and with a one term given to us, and the common difference can be a positive number, can be a negative number, and can be 0. Right? In positive number, if the common difference is a positive number, it is called increasing sequence. Because if we are adding a positive number to the existing number, we will have the numbers in the ascending order. That means it is an increasing sequence. If we are moving towards right, the values of terms will be increasing. And if the common difference is negative, negative means we are getting a negative number on subtracting A1 from A2. That means it is a decreasing sequence. The values of terms are decreasing. And when we have 0, it doesn't, it says common difference can be positive, can be negative, can be 0. And that means if common difference is 0, that means 0 added to the existing term will give us that number only. Like if I say it is -2, so add 0 to it, it will become -2. Again add 0 to it, it will become -2. Again add 0, -2. So this is, you can say, a constant sequence. Constant sequence means the terms are neither decreasing nor increasing. In that case, still it is called an AP. This is an AP, and the sequence itself is -2, -2, -2. This is a constant sequence. So next is A is 4 and D is -3. A is 4. D is -3. A2 is A plus D. A is 4, D is -3. So add 4 minus 3 is 1. A3 is A2 plus D. So add A2 is 1, add -3 to 1. It becomes -2. See, the values here are decreasing. A1 was 4, A2 is 1. So it has decreased by 3. And then A3 is -2, again decreasing by 3. So when the difference is negative, it is a decreasing sequence. A4 is A3 plus D. A3 is -2, add it to -3. This is -5. So the sequence is, or AP is, starting with 4, 4, 1, -2, -5, dot, dot, dot. Right. Next sequence is, it is A is -1. A is -1. D is half. Now A is -1. A2 becomes A1 plus D. A1 is -1. Plus A1 and A are the same things. -1, add half to it. So -1 plus half is -half. A3 is A2 plus D. A2 is now -half. Add half to it. It becomes 0. A4 is A3 plus D. A3 is now 0. Add half to it. So it becomes half. So the sequence AP is, first term is -1. Then it is -half. Then it is 0. And then it is +half. So this is the given sequence. We should write at least 4 terms. Then it is called the whole AP. Next is A is -1.25 and D is -0.25. Right? So A2 becomes A plus D. A is -1.25 plus -0.25. This becomes -1.2. Both are negative. Add them simply and write minus sign. It becomes -1.50. A3 is A2 plus D. A2 here is -1.50 and add -0.25. So this becomes, both are negative, we simply add them. So this is -0.25, that is -1.75. A4 becomes A3 plus D. A3 is -1.75 and D is -0.25. So this becomes -2.00. So the AP here becomes, A1 is -1.25. A2 is -1.5. -1.75 and -2, 0, dot, dot, dot. Right? So this is the sequence. Okay, the next question is, for the following APs, write the first term and the common difference. This is very simple. The term which is the first existing term in the sequence itself is the first term. So 3, 1, -1 minus 3. First term a1 is equal to a is 3 here. And for common difference, it is a2 minus a1. 1 minus 3, that is minus 2. And you can cross check this, a3 minus a2. This is minus 1 minus 1. This is minus 2. So the first term is 3 and the common difference is minus 2. Right? Second is minus 5 minus 1. First term here is the very first term existing in the sequence. And for common difference, we have to take common difference. It is a2 minus a1. It is minus 1 minus 5. Be careful about the signs. We have to subtract a1 from a2, not vice versa. So minus 1 plus 5 is 4. Perform one more difference. a3 minus a2 is 3 minus 1. So it is 3 plus 1, that is 4. So you can see the common difference between any two consecutive terms is 4. You can write first term is minus 5 and common difference is 4. Right? Next is first term here is 1 by 3. And then for common difference we have to subtract a1 from a2. This is 5 by 3 minus 1 by 3. That is 4 by 3. You can also perform one more difference. a3 minus a2 is 9 by 3 minus 5 by 3. It is also 4 by 3. Right? So here first term is 1 by 3 and common difference is 4 by 3. Next is first term here is 0.6. For common difference D is a2 minus a1, that is 1.7 minus 0.6. It is 7 minus 6 is 1. This is 1.1. Perform one more difference. a3 minus a2. It is 2.8 minus 1.7. This is also 1.1. So you can write A is 0.6 and D is 1.1. Yes, the next question says, which of the following are APs? If they form an AP, find the common difference D and write 3 more terms. This is a very long question. It has many parts. Here the first term is 2. For common difference D, we find A2 minus A1. First of all, we have to check whether they are APs or not. So we have to check the differences of these 3 pairs. A2 minus A1 is 4 minus 2. That is 2. And then A3 minus A2. A3 minus A2 is 8 minus 4. That is 4. So we can see that common difference here is 2. And in the second case, the difference between two terms is 4. This is not an AP. You can already do the difference. 4 minus 2 is 2. 8 minus 4 is 4. So this is not an AP. Not an AP. Next is A is 2. Then we have A2 minus A1, which is 5 by 2 minus 3. 5 by 2 is 2.5 minus 3 is minus 0.5 or minus half. A3 minus A2 is 3 minus 5 by 2. 3 minus 5 by 2. That means 5 by 2 minus, sorry, I had to write A 5 by 2 minus 2. Wait. So 5 by 2 minus 2. That is, we have to 2.5 minus 2 is 1 by 2. Or you can perform the subtraction like 2 ones are 2. This is 5 minus, this is 1. 1 multiplied by 2 is 1 by 2. So now A3 minus A2 is 3 minus 5 by 2. So it becomes like 2 is the LCM, 2 3s are 6 minus 5. This is also 1 by 2. And finally, A4 minus A3 is 7 by 2 minus 3, which is 2, 7 minus 6, 1 by 2. So yes, this is an AP. This is an AP because the common difference is same for all the consecutive terms. So now we have to find next 3 terms also. That means we have, this is A1, this is A2, A3, A4. So A5 becomes A4 plus D. What is A4? A4 is 7 by 2 and D is half. That is 8 by 2, 4. A6 becomes A5 plus D. That means 4 plus half. 4 2s are 8 plus 1, 9 by 2. And finally A7. A7 is A6 plus D. So 9 by 2 plus half. That is 10 by 2 is 5. So the next 3 terms in the sequence are 4, 9 by 2 and 5. That means 4, 9 by 2 and 5. These are the next 3 terms. In this also we have to check whether this is an AP or not. So A1 is minus 1.2. A2 is minus 3.2. We take the difference of A2 and A1. So this is minus 3.2 minus 1.2. That is minus 3.2 plus 1.2. 1 is negative, 1 is positive. Take the difference. 2 minus 2 is 0. And so minus 2. In the next sequence, next pair, it is A3 minus A2, which is A3 minus A2 is minus 5.2 minus 3.2. So this is minus 5.2 plus 3.2, right? So this is differences, 1 is positive, 1 is negative, again minus 2. So yes, the sequence between the consecutive terms is same. So this is an AP. This is an AP. So we have A1, A2, A3, A4. Next 3 terms. A5 is A4 plus D. Minus 7.2 plus minus 2. That is minus 9.2. A6 is A5 plus D. This is minus 9.2 plus minus 2. So this is minus 11.2. A7 is A6 plus D. So A6 is minus 11.2 plus minus 2. That is minus 13.2. The 3 terms are minus 9.2, minus 11.2 and minus 13.2. Right? A1 is minus 10. A2 minus A1 becomes minus 6 minus minus 10. So this is minus 6 plus 10. This is 4. A3 minus A2. A3 minus A2. A3 is minus 2. And A2 is minus 6. So this becomes minus 2 plus 6, which is also 4. Since the common difference of 2 pairs is same, we can say that this is an AP. So we have to find A6. 1, 2, 3, 4. A5, sorry. A5 is A4 plus D. A4 is 2. add it to common difference 4, which is 6. A6 is A5 plus D. A5 is 6 plus 4, that is 10. And A7 is A6 plus D. A6 is 10, added to 4, 14. So the three numbers next to these 4 are 6, 10 and 14. Next question is 3. A is 3. D, for D we have to calculate A2 minus A1 is 3 plus root 2 minus 3. So you can see that if you add them, the difference becomes root 2. A3 minus A2 is 3 plus 2 root 2 minus 2 root 2 minus A2, which is 3 plus root 2. So this is 3 plus 2 root 2 minus 3 minus root 2. So these three get cut, and 2 root 2 minus 1 root 2 is 1 root 2 or root 2 itself. So you can see that the difference here is same for two pairs of terms. So this is an AP. This is an AP. Now 1, 2, 3, 4. So we have to find A5, which is A4 plus D. A4 is 3 plus 3 root 2. D is root 2. 3 plus 3 root 2 and 1 root 2 makes it 4 root 2. Then we have A6, which is A5 plus D. A5 is 3 plus 4 root 2 and D is root 2. This is 3. 4 root 2 added to 1 root 2 is 5 root 2. Finally, A7 is A6 plus D. A6 is 3 plus 5 root 2 added to D. D is root 2. So you can add 3 remains same, and this 5 root 2 added to 1 root 2 becomes 6 root 2. Right? So the three terms here are 3 plus 4 root 2, comma, 3 plus 5 root 2, comma, 3 plus 6 root 2. These are the three next terms. Then we have A is 0.2. A2 minus A1 is 0.22 minus 0.2. So you can see that 0.22 minus 0.20 you can write. So 20. So here difference comes out to be 0.02. Next we have A3 minus A2. A3 is 0.222 minus 0.22. For subtraction, 0.222 minus 0.22. You can write 0 here. This difference comes out to be 0.002. See here the difference is 0.02 and the next pair it becomes 0.02, which are not same. So we can say that this is not an arithmetic progression because the common difference between two pairs is not same. Next question is 0. A1 is 0. A2 minus A1 is minus 4 minus 0, which is minus 4. A3 minus A2 is minus 8 minus 4. Sorry, minus 8 minus minus 4. So it becomes minus 8 plus 4, which is minus 4. So we can see that for two pairs, the common difference remains same. That means the sequence is an AP. This is an AP, right? A5 is A4 plus D. So we have four terms. Fifth term becomes A4. A4 is negative 12 and D is negative 4. Since D is negative, you can see that the values are decreasing here. It is a decreasing sequence. Negative 16. A6 is A5 plus D. A5 is negative 16. D is negative 4. So this becomes negative 20. A7 is A6 plus D. A6 is negative 20 added to negative 4. So this becomes negative 24. So being this an AP, next three terms are negative 16, negative 20, negative 24. Next number is minus half. A is minus half. And A2 minus A1 is minus half minus minus half. That means minus half plus half, which is 0. Another pair we have A3 minus A2, which is A3 minus A2 is minus half minus minus half. This is minus half plus half is 0. So the common difference is same for two pairs. This means this is an AP. This is an AP. This is a special case in which we call it a constant sequence. Though it is an AP, it is a constant sequence. So here A5 is equal to A6 is equal to A7. Each term is equal to minus half. Right? D is 0. D is 0 in this case. Next is 1, 3, 9, 27. We can, just by looking at the sequence, we can say that this is on an AP. A1 is 1. A2 minus A1 is 3 minus 1, that is 2. A3 minus A2 is 9 minus 3, which is 6. So, since the differences are not same, we can say that this is not an AP. Next is A, 2A, 3A, 4A. First term is A, and then A2 minus A1 is 2A minus A, which is A. A3 minus A2 is 3A minus 2A, which is also A. So you can see that the common difference between two pairs is same. So we can say that this is an AP. Right? Now we have to find the consecutive terms A5 onwards. So A5 is A4 plus D. A4 is 4A. 4A plus A is 5A. A6 is A5 plus D. A5 is 5A plus A, which is 6A. A7 is A6 plus D. This is 6A plus A, 7A. So the difference, next three terms in the sequence are 5A, 6A and 7A respectively. This is, first term is A, second term is A2 minus A1, which is A square minus A. This is A common, then A minus 1. Then we have A3 minus A2, that is A cube minus A square. So A square and A minus 1 is common. So we can see that these two differences are not same. So we can say this is not an AP. Next is root 2. This kind of question you must be facing in your paper, pre-boards or boards, because children always get difficulty in solving root questions. So this is very common question in papers. A is root 2. Then A2 minus A1 becomes root 8 minus root 2. Now if you know how to solve this, always factorize the bigger number. Like 8 is, right, I'm doing it here for your convenience, 2 multiplied by 2 multiplied by 2. So you have learned this in class 9. If you can factorize and take out, if a number is a perfect square, like 2 is making a pair, you can take out this 2 and 1 2 remains inside this root. So now this is 2 root 2 minus 1 root 2. These things can be solved if you know how to do it, and if it can be further factorized into smaller units. Now these are like surds, that means root 2 and root 2. So 2 root 2 minus 1 root 2 is root 2. A3 minus A2 is root 18 minus root 8. By looking at these numbers, you can say we cannot solve them. But if you factorize them, root 8 here you can write as 2 by 2 by 2. For 18, do the prime factorization. 2 9s are, 3 3s are, 3 1s are. So this becomes 3 times 3 times 2. So this is 3 can be taken out. 3 root 2 minus 2 root 2. I have factorized. I have made them a mixed surds. This is irrational part. 3 and 2 are rational parts. After solving them, 3 root 2 minus 2 root 2 is 1 root 2. So you can say that common difference is same. And if they are same, you have to find the next three terms. So what does it make? This is A4. A5 is A4 plus D. A4 means, now if you have to factorize root 32. Root 32 is 2 to the power 5. 2 16, 2 8, 2 4, 2 2, 2 1. So if I factorize these two pairs, when we take out this 2 outside, this 2 outside, so we have 4 root 2. This is 4 root 2. This is 3 root 2. This is 2 root 2, right? So we can see that these are the simplified version of these terms. So A4 is 4 root 2 added to D, which is this. So 5 root 2. A6 becomes A5 plus D, which is 5 root 2 plus root 2, that is 6 root 2. A7 is A6 plus D. 6 root 2 plus root 2 is 7 root 2. Those three terms in succession are 5 root 2, 6 root 2, 7 root 2. Right. Next we have root. Similarly, we can solve this also. This is root 3. A is root 3. Then what is A2 minus A1? It is root 6 minus root 3. Now I had told you that you have to factorize the number inside the root, that is 2 root 3. Now what you can see is we cannot take out either of the numbers like 2 or 3 outside because none of them is forming a pair. So you have to write it like this only. Or otherwise you can break them into factors. If you want, you can write it like this. Root 6 is root 2 into root 3. Now root 3 is common. So root 2 minus 1 is inside this. Try for A3 minus A2. It is root 9 minus root 6. Root 9 is otherwise 3. Right? 3 minus, otherwise you can keep them in roots like root 3 into root 3 minus root 2 into root 3. So what is common to them now? Root 3 is common. Then we are left with root 3 minus root 2 inside the bracket. So you can say that this is not an AP because the common differences in these two pairs are not same. So this is not an AP. Right? Next question is 1 square, 2 square, 3 square. You can very conveniently say that this is not an AP because they are having a large differences between them. So A is 1, A2 minus A1 is 3 square minus 1 square. 9 minus 1 is 8. A3 minus A2 is 5 square minus 3 square. 25 minus 9, which is 16. So this is not an AP. And the last question in this exercise is 1 square. Here 3 numbers are in squares and this is 73. Okay, let's see. A is 1. 1 square is 1. A2 minus A1 is 5 square minus 1 square. 25 minus 1, which is 24. So A3 minus A2 is, this is 7 square minus 5 square, which is 49 minus 25. So this is 24. And if you want to check once more, this is A4 minus A3, which is 73 minus 49. This is 49. So check, this is 13 minus 9 is 4, 6 minus 4 is 2. Yes, they all are same. So this is an AP, right? So just don't look at these numbers like in the previous question also we had squares, but see there are differences and a number like this also. So please check. Don't just rush to the answer in oral terms. Now this is an AP. This is an AP. Now we have to find A5. A5 is A4 plus D. A4 is 73. D is 24. These differences are nothing but common difference. D. So this is 797. A6 is A5 plus D. 97 plus 24. 7 and 4, 11. 1. 10 and 2 is 12. Last is A7, which is A6 plus D. That means 121 plus 24. So 145. Three terms in sequence are 97, 121 and 145. Right? So this was first exercise was very conceptual. It was all about the concept of AP and what you have learned with the basics. I hope this was very easy exercise. I hope you liked watching this video, and please like, subscribe and share it with your friends, and I will be back with the next videos of this exercise.